Section 5.5, we split across 2 days. We're solving polynomial equations by factoring. We use all of the methods that we went over back in chapter 4, such as earmuffs, quadratic formula, difference of squares, perfect square trinomials, etc., along with a few new methods that we'll learn in this section. One of the things you'll notice right away about the problems we'll be doing in chapter 5 is that they have larger exponents than the ones that we were doing in chapter 4. We always want to start off by looking for a GCF, so we look at the coefficients. Ask ourselves, is there anything that goes into both of those numbers? There is. Okay, it's a 3. We also look at the exponents. If they both have y's, we're going to take out the smaller y. So the GCF is 3y cubed. We divide everything by 3y cubed, and that gives us what's inside the parentheses here. If we were to FOIL that 3y cubed back in, it would turn back into what we started with. All right, we're not quite finished because after we take out that GCF, we can still factor this further. Y squared minus 25, hopefully you recognize as difference of squares. This is where we square root both of them. We're going to have two parentheses. One's a y plus 5, one's a y minus 5. Okay, this is our full answer. Thinking back to chapter 4, the number of terms in the problem often gave a hint as to what method we should use. If there were 3 terms, we would try to earmuff the problem. If there were 2 terms, we would try to square root it. And if there were 4 terms, that's when we would split it down the middle and we would do factor by grouping. In chapter 5, we're going to expand that. And in this problem, we have 6 terms here. Okay, terms are separated by pluses or minuses. So 1, 2, 3, 4, 5, 6. But really, we can do this with any even number of terms. So we would start off by looking to see, can we just split this down the middle? Is there anything that we can take out of the left side and the right side? And there's not. Okay, but what we should notice is that a bunch of these different terms have things in common, like this, and this all have a y. Okay, all the remaining ones have a z. So let's rearrange this and just put all the y's on the left side and all the z's on the right side. And now it looks like this. Okay, and now what we can do is we can split it down the middle and we can take a GCF out of both sides. So on the left side, 20, 15, and 10, the GCF is 5. They also all have a y. So that's going to be part of the GCF as well. On the right side, we can take out, and that's z. All right, so once we do that, we have our 2 parentheses. These parentheses come from just dividing everything on each side by the GCF. And in both of these cases, it turns into 4f plus 3g minus 2h. Notice these parentheses are the same. They should always be the same. If they're not the same, we did something wrong or the method doesn't work. So those same parentheses is 1/2 of our answer. The other half is made up of the GCFs we took out. So 5y minus 4z. New equation form, and this one is more complicated than any of the ones we've gone over so far. If we have 2 cubed numbers or 2 cubed variables and they're separated by a plus or a minus sign, we can factor them according to one of these 2 equations, depending on if it's a plus or a minus. When we write this out, notice that there's always just one minus sign regardless of which equation we use. Okay, if it started with a minus sign in between them, the minus sign comes first. Okay, if it started with a plus sign in between them, the minus sign goes in the middle. All right, so now why does this actually work? If we look at this bottom one and we took this first term, okay, and we distributed it to everything, okay, we would get this top line here, a cubed plus a squared b plus ab squared. If we did the same thing with that b, or really a negative b, we would get this bottom one, negative a squared b minus ab squared minus b cubed. What happens with these 2 equations is that these terms in the middle are always opposites of each other. They're always going to cross each other out, and we're left with just a cubed minus b cubed. Okay, if we FOILed at the top one, we'd have the same thing, except it would be a plus b cubed at the end. With that in mind, let's do this example problem. We have 2w to the 4th minus 54w. When it comes to any factoring question, we always want to start off by looking to see, is there a GCF? So if we look at this 2 and the 54, is there anything that we can divide both of those by? Okay, if we look at the variables, do they have any variables in common that we can take out something from both of them? So obviously the GCF is 2. They also both have at least one W, so we're going to take out a 2W. Okay, we divide both of these terms by 2W, and we get what's inside the parentheses here. So to go through the steps, the 2's would cancel, subtract exponents. Here we would have 27, and then the W's would cancel. All right, so now let's look at the inside of this parenthesis. We want to see if we can factor this further. So we have a W cubed, right? And then we have a 27. And one thing that you're going to have to start recognizing in this chapter are perfect cubes, okay? Numbers that result when we cube another number. And 27 is the result of 3 cubed. So I'm going to rewrite that like that, W cubed minus 3 cubed. So this is an example of difference of cubes, which was on the as an equation on the previous slide. I'm going to copy it over here. And next question is, what's the A, what's the B? Well, the A is just the W, and the B is a 3. We're just going to plug everything in to this equation. Okay, now I have the GCF out front still, so that 2W is still out front. And then I just put a W anywhere that I saw an A. And I put a 3 anywhere I saw a B. Okay, and now we're here. And as a last step, we want to simplify this as much as we can. So this we would just write as 3W. This 3 squared equals 9. And this is our factored answer.